Hey everybody, Eric Snyder again. I want to talk to you today about ignition timing. I had mentioned before I have to change the timing on my Camaro with the MSD flying magnet crank trigger system. So what I want to do is just go over today. I want to go over ignition basics, the 4 strokes of an internal combustion 4-stroke engine, and how ignition time and ignition works, and what different mechanical things are happening, and how and why ignition timing is important. So I'm going to switch around here and have some visuals for you that hopefully help you understand ignition timing and what's all happening. Okay, so I'm going to take you around here. The first one would be the intake stroke. There's four cycles in a 4-stroke engine. Really, it's 2 revolutions of the crankshaft. But the first one is the intake stroke. So I'm going to try and zoom in here, and I'm going to try and explain what's going on. Okay, so up here we have the intake stroke. This is your first action that's in the whole 4 cycles of the engine, is your intake. So as you see here, the intake valve is open. The intake valve is open so that way it's allowing air and a fuel mixture to go inside the cylinder here. Okay, so what you want is this to get filled. And the piston, as you can see, is traveling down. As the piston travels down, it's creating a vacuum, kind of like similar to like your household vacuum cleaner, a shop vac. But it's creating a negative pressure here, so it helps suck air into the cylinder. So as the piston's going down, it's creating this vacuum. Not only is the valve open, but it's having this vacuum effect. So you want to fill the cylinder with as much air, with that much fuel as you can. So as you can see, the intake valve is open, the piston is traveling downward, and a vacuum is being created. Okay, so that is the first stroke in a 4-stroke engine. So next would be your compression. Okay, compression is, you have both intake and exhaust valves are closed. Okay, so the piston is now coming up. So your crankshaft's rotating, your piston's coming up, and it's at the top of its travel. And as you can see here, I have these lines here. They show pressure. It's compressing it, taking something from a big volume, and it's compressing it down. Now, when that happens, that also creates heat. Anytime you rub molecules together, it's going to create heat, which also helps aid in the ignition. But the more compression you get, the more power you're going to get, because you're compressing that. And then when that gets ignited, those molecules literally explode. And the more you compress them, the more they're going to explode, the more power you get. That's the theory behind it. So the next one will be that it's actually 2 things going on. It's called ignition, but it's also known as the power stroke. So basically, you still have your intake and exhaust valves are closed. The piston, when it comes up, is still stationary, okay? And then what ends up happening is the spark plug fires, okay? So that's what's signaled here. The sparks coming out of the spark plug. Here by the orange is your fuel mixture starting to burn, starting to burn and combust, if you will. And when that happens, it takes your piston now, and it's going to literally slam it down, which creates the power. It's going to turn the crankshaft, which in turn is going to be usable power, usable motion, usable direction of the engine. So this is very complicated, because you have 2 things going on. You have ignition going on, but at the same time, you have the power stroke, which is when this gets ignited, that explosion happens that I said about. It's going to go literally real small and bang, like that. I mean, quicker than that. And it's going to drive that piston down along with the crankshaft, which is going to make your horsepower, if you will. And then finally, last but not least, is the exhaust stroke. So basically, your exhaust stroke is your exhaust valve is going to open up. And now all the spent gases from the explosion that happened to create the power is all in the cylinder. So before we can bring a new charge in, we have to get this gases out. So your exhaust valve is going to open. The piston is now, signaled by the arrows, is going up. This is the crankshaft pushing it up, because there's no longer a force pushing it down. The crankshaft is going to push the piston back up. As the piston goes up, it's going to push those exhaust gases out this valve, out the port, ultimately out your exhaust. So that's kind of like a quick overview of the 4 strokes in an internal combustion 4-stroke engine, which is pretty much every car on the road today has internal combustion engine. Now, with that being said, I'm going to take the opportunity here. Sorry about that. Let me switch around here a little bit. I'm going to take the opportunity to explain the crank trigger system real quickly. And I'm going to use figures that I'm using for my Camaro, okay? You can use any figure here. I'm using the 40 degrees before top dead center. A lot of people can go anywhere from 36, 37 to 40 or 42, I've heard already of people doing. But basically what you're doing is the crank trigger, and I don't know if you can really see it, but you have your crank trigger wheel and an MSD crank trigger wheel, which is mounted to the front of your crankshaft, or I should say your harmonic balancer. And then what it has these here are magnets. There's 4 magnets. Sorry about my artwork isn't the greatest, but they're mounted 90 degrees from each other. And basically what the magnets do, they tell the magnetic pickup, it signals at what position the crankshaft is at with these magnets. Okay? So basically you have your slider, which is what the pickup adjusts on. You have the slider block, and then you have your magnetic pickup, which is here, and that's what gets receives the magnetic field, or the signal, if you will, when these magnets pass by your magnetic pickup. Okay, with that being said, what I'm going to go through here is on paper what I'm going to do with the Camaro. Okay, so I was told between 38 and 40 degrees before top dead center. Top dead center, again, is when the piston is at the highest of its travel in the cylinder just before ignition happens, okay? So it's like between the compression and the power stroke. So anyway, so what you want to do is you have your top dead center mark on your harmonic balancer, and I should have drew another figure here. But your top dead center mark is here because remember, when an engine is running, it actually turns, your crankshaft's going to spin clockwise. So you're actually going to turn it counterclockwise. Your top dead center mark is going to be here, okay? And whatever you want, if you want it at 40, you want it at 36, you want it at 38 before top dead center, that is going to line up with your timing pointer, okay? And you're going to want that lined up. Now, when you have that, whatever value you're going to use for your base or static timing, you're going to want it that it lines up with your magnetic pickup, okay? And your magnetic pickup, you kind of want to have in the middle of your slider mount here. So that way you have adjustment if you need to adjust timing by smaller increments, okay? But you want your basic to be in the middle so you have room for adjustment, okay? So 40 degrees before top dead center. Okay, what is before top dead center? It's before the piston gets to the top. Remember, in the figure we had, the piston was at the top of its travel, okay? And then we fired the spark plug to create the explosion, to create the power, right? So that takes time for this to read the magnetic field, to send the signal to go to MSD box, the MSD box to signal to your distributor, and then to fire your spark plug. It takes time. That's what timing comes in with. So you want to have that spark happens at exactly the highest part of the piston travel, because if you have it after, you're going to lose power. If it's too much before, it's going to knock and detonate, okay? So, that being said, that's the trick with figuring out this. So, anywhere like 36 to 42 is a good range to start to do your static or your base timing. So, start with that. So, okay. So, we got 40 degrees before top dead center. Okay, we got it lined up here. Okay, here's your top dead center mark. Okay, and this is about where your piston would be. I'm guessing, but you're not at the top of your piston travel. You're actually before it gets to the top. So it's about here. Okay, that's probably where 40 degrees before top dead center would be. Okay, now let's look at actual ignition. Okay, here's the actual ignition. We're at your top dead center mark is at your timing mark, which is, I guess, what you could refer to as 0 degrees timing, okay? So your magnet is down here now, okay? That was lined up before. So now your piston is at the top of the cylinder at its travel. You have your intake charge, which is being ignited by the spark plug. So you're at top dead center, and if your 40 degrees is right, it'll fire like that. And that's when you're going to get the most horsepower, is when you fire that spark plug right at the top of the piston travel. So with that being said, I hope that kind of helps understand. That was a little bit quick. Feel free, pause, rewind, whatever you need to do. But that's the 4 strokes of a internal combustion 4-stroke engine. I hope it helps. I hope it helps you understand timing. I'm going to try to get a video of me actually doing the adjustment for the crank trigger on the Camaro. Hopefully soon. I have to see how things line up. If you could, comment, like, subscribe to my channel. I'm going to try and have some more good content shortly. That's all for today, and have a great day, and we'll talk to you. Take care of each other.